So we start today on page 13. We will take a look at our calendar, and before we do, I thought that I handed this out on Friday, but maybe I didn't. In fact, I don't think I did. This is the grading choice. Now, I think that folks have already kind of solidified one, but just in case you've had second thoughts or more time to think about things, I'm just going to pass this around. If you make a choice, don't use red or blue. I don't care what color you use, but put big stars that says, hey, relook at this row, because it's quite annoying actually to look at all the numbers in my Excel spreadsheet that are here. So I only want to look at the ones that are changing if they are changing. So we'll just pass this around. No need to make a change, but if you feel like you're making a change, this is the last chance to do it, okay? Yeah, make a big star if you're making a change right now. It doesn't matter what color we use. All right, so again, quiz number 3 was right now, but it was a lot longer than I thought it was, and so, but I don't want us to spend as much time in class doing the quiz as I think it takes to do that quiz. So I'm sorry to give you a little bit more work to do at home, but let's have this turned in first thing on Friday. I'm going to trust you guys to follow the same rules when you take this quiz at home as you're following now. That is, no book, no class notes, no talking to people about the quiz, no calculator. Pretty much the only thing I'm giving you is more time to take this quiz, right? So take it at home. You can still use your index card. Just there's no time limit now. Angus? Either way, it's fine. Yeah. If you already finished, you can put it in the folder, or you can take it home and just look at it again. Either way is okay. All right, today we are going to briefly review composition of functions. That's a pre-calculus or algebra topic. Then we're going to talk about the chain rule. What are we talking about next class? The chain rule. So that gives you a sense of how important this chain rule is. We're actually going to spend the better part of 2 classes talking about one rule. Now we've seen a lot of different derivative rules so far. We had power rule, we had exponential derivatives, we had product and quotient rules. We're going to see more soon enough. Derivatives of trig functions, derivatives of inverse, derivatives of logs, and then finally one big overview on all the derivative rules. So there's a lot of derivative rules that we're kind of right in the middle of right now. But hear me clearly, the chain rule is the most important derivative rule you will ever find. One more time, the chain rule is the most important derivative rule you will ever find. That's why we're spending 2 days on it. Also, what's happening this coming Friday? Project number 3 is due, so hopefully you've been working on it. And then project number 4 is assigned. If you're ready to start on it, they're sitting up there. I'll pass them out on Friday, but if you want to grab one today, you're welcome to. But that's what's happening Friday. Any questions on the calendar? Okay, so again, we are on page 13. And we are going to kind of jump around. I've highlighted the key topics, the things that we're going to focus on. There are going to be a bunch of blanks left over here. There's just not enough time for us to do all of these together and still have you guys have a chance to practice in class today. So we're going to skip around. Feel free to fill in the other blanks at home if you want more practice. But we'll start with a real quick review of composition of functions. So in this example, I've got 2 functions. F of x is e to the x. And g of x is 3x plus 1. Can you guys find 2 things and check with your neighbors? F of g of x, and then the other order, g of f of x. So find those 2 highlighted things, double check with your neighbors. Let's come on back together. It looked like most groups were winding down. So the first one was e to the 3x plus 1. And then in the other order, 3 e to the x plus 1. Any questions on either of those 2? So the basic idea with composition of functions is where do you start, outside or inside? We start with the inside, right? You figure out what's going on inside, and then you work your way outside. Okay, so again, are there any questions? Because if we don't have a good sense of what these 2 things are, then we're going to have real trouble with the calculus part that's coming up. It's okay? Okay, so let's move on now to the next section. Instead of giving you 2 functions and asking you to make one brand new one by composing, we're going to go the other direction. I'm going to give you a function that has been composed, a function that came from 2 simpler functions, and then we built this composite function. In this case, it's ln of x cubed. Now, we'll talk about ln in just a couple of classes in lots of detail, but suffice it to say, it's just a function. It stands for what? Natural log. So let's see if we can split this thing up into 2 functions. What are we going to do here? We're going to let f be the outer function, just so we can be consistent. We'll let G be the inner function. So can you guys do the two highlighted ones here again? You're going to tell me what the inner function is and then what the outer function is for B and H. And again, check in with your neighbors, and if the person sitting next to you is not writing anything down, then bring them along. So for the first one, part B, what is the inner function? X cubed. Okay, so then finding the outer function, this is where some people get tripped up a little bit. What is the outer function? It's ln x, just x. The x cubed part is already taken care of with the g function. So this is just ln of whatever you had up above, ln of x cubed. Any questions on that one? Okay, now it turns out that this kind of question where I say, you know, write it as a composition, there are infinitely many ways you can do this. I'm guessing that everybody in this room did what we did up here, but maybe we could do something like this. G of x is x, and f of x is ln of x cubed. True or false? Compose those and you'll get ln of x cubed. So the g is the inner one, and instead of the x in the bottom function, we just put x. And so we get ln of x cubed. So it's true. It's also entirely useless for what we're about to do. You could come up with even crazier things. You could say, all right, I'm going to say that g of x is something like the sine of x, which isn't at all inside of this yellow ln of x cubed. Okay, so I can fix that. Let's see. So ln of x cubed, ln of somebody cubed, but somehow I need to get rid of that artificial sign that I put in there. We'll talk about it, but the opposite of sine is arc sine or inverse sine. So I could do something like that. Okay, so that's not as trivial as the first one, but it's also just as useless. In fact, it might be more damaging than the first one. So I'm hoping that when I say, you know, decompose them in the natural way, that we all kind of head in the same direction. Okay, so how about in part H, the inner function I have is x squared minus x plus 1. What's the outer function? X to the 23rd. That's it. What does the outer function do? It takes the inside and raises it to the 23rd. All right, any questions on any of those things? Okay, merrily moving right along, come down to the chain rule. So the chain rule is going to allow us to take a derivative of f of g of x. What word have we just been using that describes f of g of x? That's a composition. So we are about to learn how to take the derivative of the composition of two functions. Okay, so this derivative rule is written out in a couple of ways. On the one hand, it's f prime of g of x times g prime of x. And I'll just make an observation. I know it's a lot of symbols and they'll have more meaning when we actually apply them, but I will say basically this is f prime times g prime. Do we see it? Like if you just kind of don't look at what's going on inside of the functions, it's f prime times g prime. So somehow when we compose functions, we're just supposed to multiply two derivatives together. Unfortunately, it's just a little bit more complicated that the first derivative isn't f prime of x, it's f prime of g of x. Second one is just g prime of x, that one's fine. But the first one is just a little bit more complicated. And then there's the Leibniz way of writing things, dy dx, that's his symbol for the derivative. And what do we see if we just kind of put on our blinders? This is really a multiplication, right? We're multiplying two things together, yes? In the same way that up above, I wrote in blue, f prime times g prime. So we're multiplying two derivatives, no matter how we slice it. So we're going to do a problem each of these ways, and then you guys are going to pick which one you think is better for you. All right. So let's jump down to number 3. It says find the derivative. And we're going to find the derivative of part C, the 23rd power one. Okay, now hopefully this looks a little bit familiar because it's the function that we just had up above, right? It's the same as this last one we did. Okay, so let's go with the f and g version because we have that in front of us at the moment. So here's what the rule says. It says you're going to multiply f prime times g prime. So let's write out those two things. So for this one, we'll put it over here and we'll move up a little bit. F prime of x and g prime of x. Those are the two things we need. You have them on your page. What is f prime for part H up above? 23x to the 22. Everyone agree? That's f prime. Okay, somebody test today? Yes, we do. I'm right now just going to find f prime and g prime of x, and then we'll fix it, but you're right. Okay, somebody we haven't heard from yet. What is g prime? Owen. Everyone agree? So we've got our two derivatives, we decomposed, we had our two functions, basic derivatives. Okay, as Tassadé points out, we're not quite done with this one because it didn't say f prime of x in the formula. This is here in purple. It says f prime of g of x. So we have a tiny bit more work to do. F prime of g of x is what we're after, which means f prime of, and then I'm just going to copy the g of x formula. You guys have it, it's right off the screen. What is the g of x formula? X squared minus x plus 1. So the g of x just got replaced with the definition for g of x. It's right above. And then again, this is the sticky part for some people. I have my f prime rule. F prime is 23x to the 22. But I don't want f prime of x anymore. I want f prime of this complicated green stuff. So instead of the x, 23x to the 22, it's 23 green to the 22. Combine it. What we're doing is we're replacing the x with what's in green. That's what's in the parentheses. So at the risk of over highlighting, there's an x, they become whatever the green thing is. So this is equal to 23 times something to the 22. That's the basic rule for f prime. What's the something? Is that green? X squared minus x plus 1. That's not easy. The rest of this is going to be real easy to finish this problem. Are there questions on that? Steve 2, what do you think? Okay, so the x squared minus x stuff. All right, so if we, yeah, that's the original. Yeah, we copied g of x from up above. Yeah. Everybody okay? All right, so we're ready to bring it home. We just have to get our final version. Again, it's here in purple. F prime of g of x, that's the one piece we just finished, times, chain rule always has a times in the middle, g prime of x. We have that down here as well. So all we're doing is multiplying. I will circle in red. That's f prime of g of x. That's g prime of x. The chain rule says you multiply those two things and you stop. So what was the original name? Was it y? Okay, so that means that y prime is equal to the product of the red things. Red times red. Break it up, find the different pieces, multiply them together. I have made a mistake. Two x minus 1 is a single thing. That's mandatory. And in fact, you won't go wrong if you just put parentheses every single time. Because chain rule is always multiply two things. Just make it a habit. Put them both in parentheses. You won't go wrong. This is the answer. Yeah, in terms of simplifying, like we're not going to spend time today simplifying, but again, the goal is almost all the time for us going to be to set the equation equal to 0. And I would argue that this is in a really good form to set the equation equal to 0 because it's all multiplication. Everything is already factored. So I think setting it equal to 0 from here is a good way to do it. Okay, so that's the f and the g way to find the chain rule, to find the derivative. Now, I've been doing the chain rule for many years, and just this morning, I feel like I decided that I didn't prefer the f and the g way, but rather I prefer the Leibniz way that we're about to do right now. So you guys will, again, pick whichever one you think is better. But this, we're going to do the same exact problem and make sure we get the same exact answer. But now we're going to do the Leibniz way. So we're up here in green. So here's what Leibniz says. He says dy dx, that's just a derivative, equals dy dz, I don't know what z is, times dz dx. Okay, a couple of nice things about this. First of all, it's a product, just like the chain rule was a product up above, right? So however you slice it, the chain rule is a product. The second thing is, if I naively treat all of these things as numbers and just think of like multiplying fractions, what would happen if I asked you to simplify? Wouldn't you just cancel those dz's and you get exactly dy over dx? No, we can't do that because they're not just numbers. But at least it seems like reasonable, like it looks good to me, that dy dx maybe is equal to whatever it says it is. So let's give this a shot. First thing we're going to do is we're going to figure out what y and z are. And I will tell you they are the same things as g and f. Z is going to be the inner function, y is the outer function. So same problem we had up above. Z is the inner function. What is z? It's x squared, the inner function, minus x plus 1. So we're just renaming it. It's going to be the same basic setup, but just using different letters. So z is the inner, it's the g of x, and y is the outer. So what is y? Is x to the 23rd, right? Okay, don't write that. I hope you didn't write it. X to the 23rd is not quite how we want to write it. There's this little note up here. It says z is the function, nope, not that note. It says y is a function of z. So we don't want y to have x's in it. We want it to have z's in it. So instead of x to the 23rd, z to the 23rd. And actually, I like that quite a bit because if I told you that y was z to the 23rd, and right up above I told you what z is, do you buy that y is exactly what it is up above? In some sense, I think that's even less confusing than the composition of functions way we wrote up at the top. Because up at the top, x changes roles. Whereas here, it's two different letters. There's an x, but then there's a z, no changing roles. All right, so now let's see if we can find these pieces. So dy dz and dz dx. I don't know that we have a lot of practice with recognizing exactly what's the equation we're looking for and what's the variable. So let's practice right now. Dy dz we're going to put right here. What it says is find the equation that says y equals and find the derivative where z is the variable. Find the y equals equation, z is the variable. So my y equation is the bottom one, z to the 23rd. Just take a derivative. It's z instead of x, but that's fine. What's the derivative of z to the 23rd? It's 23, z to the 22. That is mimicking the f prime that we did before. We're doing the same thing. It's just a matter of how we write it. And then the other equation we want is dz dx. And again, those symbols mean find the z equals and take an ordinary derivative. So the z equals is your first equation. What's the derivative of the first equation? That was the second one. So right now we're doing the z derivative. 2x minus 1. Everybody with me? Yes. Z dx means z equals, that's the equation we're looking for, and x is the variable. So whatever's on top, that's the equation you're looking for. And then Leibniz's version just says to find the derivative, what do we do with those two things? Multiply them. That's what it says. Multiply dy dz times dz dx. So we're just going to multiply these two things, and that will be our answer. So these two guys come down here, and we say dy dx, that's the derivative we've been after from the beginning, equals just the product of those two things. 23 z to the 22 times 2x minus 1. Again, you won't go wrong by putting parentheses around each of those two parts every time we do the chain rule. Okay, the only downside is that the original problem here is still highlighted in yellow, had only what variable on the right? X. And it is quite strange to give an answer with Z. We invented Z. It doesn't really belong in our final answer. So what do? Instead of Z, x squared minus x plus 1, right? That's what Z is. So this is really 23, and then Z is about to change to the 22, and then 2x minus 1. But again, instead of Z, you just put what Z is equal to. It's all those x's, x squared minus x plus 1. Yeah, I would leave it just like that. Is that the same as the answer we got before? Yes. So again, all the chain rule says, find two derivatives and multiply them. You just got to be careful about what the variable is and what equation you're after. Okay, can I just get a sense? You guys are going to, right now, just temporarily pick which one your instincts say is better for you. You have to raise your hand for one of these two options. There's the F and G version, or there's the Z version. So raise your hand if you prefer the FG version. Raise your hand if you prefer the Z version. All right, that's about the opposite to what we had in my first class, which is okay.
I just like that. Replace the Z at least.
Yeah, replacing the Z at the end has an analog.
I feel like I'll get to do it and
And just leave it with Z. Yeah, that makes sense that you're worried about forgetting to do it. I will say that the replacing the Z is exactly what this step was,
right.
Where instead of 23x squared, it became 23 times all those x's. Yeah. Okay, next page. We are going to, again, skip around a little bit. We're going to do part B in here. So most folks preferred the F and the G business. So we'll do the FG version right now. So the idea is, again, we'll let G equal the inner and F equal the outer. So first see if you can decompose that ln of x cubed into an inner and an outer. What's the inner function? X cubed. Outer function? Ln of x. And once we've got it decomposed, now it's a matter of just following those rules, finding all the pieces. So we need to find G prime, we need to find F prime, and then finally we need to find F prime at G. These are always the three things to find when we're doing the FG version of the chain rule. So let's find the pieces together. G prime. G is x cubed, 3x squared. Okay, now we get to F prime, which means we're looking for the derivative of ln. Now we have not talked, we're going to spend a day talking about log functions, and then we're going to spend another day talking about the derivatives of those kinds of functions. But for right now, take my word for it, I've given you a rule up here that says that the derivative of ln of x is 1 over x. We'll talk about why that's so soon enough. But for right now, let's just see if we can use it. So let's see, ln of x becomes 1 over x. So what's the derivative of f? What's the derivative of ln of x? 1 over x. Just write it. Just a new rule. We will talk about it soon enough. But if I give you the rule, I'd like you to be able to finish this problem. So then what we're doing is we're plugging g into the f prime function. Now for me, I always like to write that as a separate step, where instead of g of x, I put the rule. What is g of x in this case? Is x cubed. Okay. G by itself is x cubed, not g prime, just g. Okay, and then f prime is the 1 over function. It's 1 over whatever is in the parentheses. So this is the hardest part. What's f prime of x cubed? 1 over whatever is in the parentheses, 1 over x cubed. That's the tough part. Pass the day. So, okay, so we are doing a lot of steps because I want to make sure that that we see all the pieces coming from that main definition. And every time I give you a new derivative rule, I'd like us to be able to go back to kind of first principles, which is what I feel like is here. For me, and hopefully for you guys soon enough, you're going to have these kind of like special rules that all follow from the chain rule. And so we'll talk about these on Friday. But for example, here is a new special rule for this thing highlighted in yellow over here. If you have some stuff to a power, here's how you find the derivative. The power comes down just like it always does. You copy the stuff, normally it's x. You do what to the power? Subtract 1, that's the normal power rule. But then the chain rule says you got to pay for it. You multiply by the derivative of the stuff in the parentheses. Okay, so let's look at our final answer here. We'll look at the thing in black at the bottom. So the 23 comes down, you copy the stuff in the parentheses, you subtract 1. That is all over here. 23, copy the stuff, subtract 1. The only new thing that the chain rule says is, okay, you got to pay for it. If it's not x, you multiply by the derivative of whatever was in the parentheses. So ultimately, I'm really hoping we don't do all the f and the g prime and the f prime stuff, because there are nice little shortcuts that make it a lot faster to do these problems. But for right now, I don't want to give you, oh, here's a special way to do this and here's a special way to do that. I want the general, like the one thing that works all the time, and then we can kind of get specialties from that. All right, so let's finish this one here. So we've got that. I think we're ready. We just need to find the two things to multiply together. Chain rule derivative just always multiplies two things. Can you guys find the two things in this list of 5 things we've written to multiply together? So it's the g prime of x and